The following is the video solution from JSDT Solutions. Question 7 says the diagram below shows two vertical poles, AD and BC. Point E lies on the same horizontal plane as the bases D and C of the poles AD and BC. And then they tell us these angles that we have. AB is equal to 2 alpha, BEC is alpha, ABE is 90 degrees minus 3 alpha, and BC is y meters. And the first question is to determine BE in terms of alpha and y. Okay, so in terms of alpha and y, since we're trying to find BE, you see that BE in terms of alpha and y would be using this triangle over here, BEC or BCE. So we can use, because this is a right angle triangle, we can use trig functions on this. So using alpha as our reference angle and using y because it's a side we actually have, and BE since it's a side that we are looking for. So you see that we are using the opposite and the hypotenuse. Opposite and hypotenuse means that we need to use sine, okay, in SOHCAHTOA. So this is sine of our reference angle alpha is equal to the opposite over the hypotenuse side. So that is BC, which is y, over our hypotenuse, which is BE. So over BE. And all we have to do here is make BE the subject of this formula. So if you cross multiply it, or you can actually just see it as transposing. Since this is in the denominator, when you transpose it, it'll go to the numerator. So it's BE. And then we need this to move. It was originally in the numerator because it has a natural denominator of 1. When you transpose it, it's going to go to the denominator. So this is still y in the numerator over sine alpha in the denominator. And that is our answer. Question 7.2 says, show that AB is equal to 2y. Okay, so seeing that we just found BE to be y over sine alpha, just remember that this has already been found. And now we need to show that AB equals 2y. Okay, so with that, we can use this triangle over here because it includes this side, BE, and it also has angles in them. And using this, because we're trying to find AB, we can use the sine rule. But with the sine rule, we're going to have the angle opposite that particular side we're looking for. And here we have that. That is 2 alpha. Now here we need to have a complete pair, a side available with expressed in terms of something. And then we need to also have the angle opposite it. So we have BE and we're going to use that angle. Okay, so we can actually find this angle since we have two other angles in this triangle. So this angle BAE is equal to, so let's go ahead and find that first. Angle BAE is equal to 180 degrees minus the other angles that we have there, which is 90 minus 3 alpha and 2 alpha. So we can say minus 2 alpha and then minus 90 degrees minus 3 alpha. So we're using brackets there because we had two terms here, so it has to apply to both. So that's 180 degrees minus 2 alpha minus 90 degrees, and then that becomes a plus 3 alpha. So this is equal to 3 alpha minus 2 alpha is alpha. 180 minus 90 is 90. So this is just 90 degrees plus alpha. Okay, so that is the angle BAE. And now that we have that angle, we can finally use the sine rule. So we're trying to find the side AB. So we're going to say the side over sine of the angle opposite it. The angle opposite AB is 2 alpha. So this is AB over sine 2 alpha. And this is equal to, we're taking another pair that is complete. This over here is now 2 alpha plus 90 degrees. And so this is simply just the side BE, which is y over sine alpha. And we're going to say over sine of this angle. Okay, so that is So y over sine alpha, and we can just say divided by sine of that angle, 90 degrees plus alpha. Okay, now with that, you see that it has a denominator of 1. So we can just use tip and times over there. So long we'll just have AB over sine 2 alpha is equal to y over sine alpha, and that multiplies by 1 over all of that. Okay, so 1 times y still stays y, but the denominator is now going to be sine alpha times sine 90 degrees plus alpha, which is actually a cofunction. So this will simplify to cos alpha. Okay, and that's what we have. Then we can go ahead and transpose this since we need AB on its own. Okay, so AB is finally equal to, we're moving it from the denominator, so it goes to the numerator, and it is sine 2 alpha. But you see that we can use double angles to just expand that. So that's going to be times 2 sine alpha cos alpha, and this goes all over sine alpha cos alpha. And like that, what will happen is the sine alpha and sine alpha cancel, and the cos alpha and cos alpha cancel, and you're just left with 2 times y. So that is why AB is therefore equal to 2y. And that is our answer. Question 7.3 says, it is further given that AF is equal to 7 over BC, and they tell us to determine angle BAF, the angle of elevation of B from A, and we need to give our answer to the nearest degree. Okay, so it needs to be a whole number that we get as the final answer. Okay, so let's put that down. So AF is equal to 7 over 4 BC. So it's been named in terms of BC. AF is 7 over 4 BC. Okay, where is BC? BC is over here, which is y. Okay, so we'll just keep that in mind. That's just y. And then they told us to find this angle over here, BAF. Okay, so we are working with this right-angled triangle. And we have been told that this is the angle we need to find. We have been given this side. So this is the side adjacent it, okay, adjacent that angle. And we already have AB. With AB, that was 2y. Okay, so that makes perfect sense. Since this is 2y, they will both be in terms of y. So this is 2y. And since this AF is 7 over 4 BC, and we know that BC is y, let's just tell them what AF is. AF is simply equal to, since it's 7 over 4 BC, we're just going to put y there. So 7 over 4y. So they're both in terms of y. Therefore, we can just use this right angle triangle to find this angle. So in reference to this angle, this is the adjacent side. And this side that we have here is the hypotenuse because it's right opposite the right angle. So we'll be using adjacent and hypotenuse, meaning we're using cos. So let's say cos of this angle BAF is equal to, and we're saying the adjacent side, this, okay, 7 over 4y over 2y. And that's what we are going to work with. Okay, so cos of angle BAF equals 7 over 4y divided by 2y, which we already had. Okay, so y's would cancel, and this is really just 7 over 4 divided by 2, which you can say multiplied by 1 over 2. And so that is just equal to 7 over 8. So we're saying that cos of angle BAF equals 7 over 8. So to find this angle, you see that we're going to have to get rid of cos. So we can use the second function of cos, the inverse of cos on both hand sides. So therefore, we're saying that angle BAF is equal to, and we're just going to say shift cos on our calculator of 7 over 8 and find out what that gives us. So on the calculator, if you say shift cos 7 over 8, and we need to round off to the nearest degree, so the nearest whole number. So That 9 is going to round up, and that's going to add a 1 to the 8. So this is simply 29 degrees, and that is our answer. And that is it for question 7.